Hello everyone, my name is Andrew, the Bazooka Prophet, and today we're working a very interesting video in organic chemistry, which is what we call the Aldol reaction. Now, an Aldol reaction and an Aldol condensation are not the same. An Aldol reaction is a type of reaction in which two molecules of an aldehyde or a ketone, and this aldehyde or ketone must have an alpha hydrogen. Take note, an alpha, because the difference between an Aldol reaction and a Canzaro reaction is that an Aldol reaction must have an alpha hydrogen, while a Canzaro reaction lacks an alpha hydrogen. So we said that two molecules of an aldehyde or a ketone in the presence of a base, we yield what we call a beta hydroxycarbonyl compound. A beta hydroxycarbonyl compound. A beta. Remember, if I'm having a functional group of this nature, which is an aldehyde, the first carbon there is called the alpha. Called the what now? It's called the alpha carbon, the beta carbon. Now, this is for an aldol reaction. While an aldol condensation, from what condensation, smaller molecules are what now? Are removed. You get me now? So an aldol condensation is a type of an aldol reaction that has lost a molecule of water by what now? By dehydration. By what now? By dehydration. And take note, these aldehydes containing the alpha hydrogens, we undergo what we call a self-addition in the presence of a base to form a product called an aldol. And that is why the product formed from an aldol reaction is always longer and larger. At the same time, it contains two functional groups, which are the aldehyde and the alcohol. That is where the name comes in. Aldol, aldehyde plus an alcohol. Now we move straight down to the reaction, or like the very popular reaction, which is what now? The acetaldehyde. Now if I'm having two molecules of acetaldehyde in the presence of a base, now what will happen? Very, very simple. Now what do? The shortcut of it is very simple. Come here. It should be like this, while the other should be okay, while the other should be of this nature. So let's go. Now it means that the first acetaldehyde, which is something of this nature, plus the other one, which is the next aldehyde, so this is what you have. Now this is what we call, this is an acetaldehyde to another acetaldehyde. Very, very simple. These two react together in the presence of a base. See, you clean this functional group here, this from this functional group, then you remove this alpha hydrogen here. It will not be placed here. It will not be placed here. Then afterward, you just come and combine them together. Very simple. So then become a CH3 and alcohol. Then having an A share, that is how simple it is. This is what we call an aldol containing the alcohol and the water carbonyl. So the name of this compound here you are seeing here on the board is called what now? It's called hydroxy what now? Butanol. So this is what we call an aldol reaction. This same aldol reaction can undergo a dehydration reaction, which we call an aldol condensation, to form what we call, so to remove what I look at it. It's the same thing, the same rule that has been obeyed. So that the another hydrogen is removed from the alpha hydrogen, then for this OH here, which is alcohol, to give what we call a CH3. A double bond is now being introduced. It's now being introduced to give what we call but2-enal. But2-enal. Okay. So the next on example is what we call the reaction of two butanol, like two CH3, CH2, CH2, then CHO. We move straight down in the presence of a base. So let's move quickly. Now, very simple. The same rule applies. In this one, remember I told you that the pattern is just like this. Why? Pattern of this one is just like this. Simple. Please take note. Alpha, alpha, alpha. So we move here straight down to here becoming like this. Which is the first one. Take this pattern CH3, CH2, CH2, then this is the first pattern. While the second pattern, this case is not quite different. Take note, it's quite different. So it means that this is the first carbon, this is the alpha, outside the functional group, the alpha. So you have to explore this alpha, which will not be of this nature. The alpha, move straight down to, so this is the functional group. So CH2, CH3. You get? So remember, you are having something of this nature. So what you have, the same will also apply. Remember that here I've already come here, which is the alpha carbon, which has been exposed for attack. Now you just clean the same one here. This one comes here. That's shortcut. Then afterward, the two joins together. Very simple. So what do we do? So here becomes CH3, CH2, CH2. Then move straight down to this is OH, H, then C, H, then CH3. Again. So the product here now becomes as 2-ethyl, 3-hydroxy, 1, 2, 3, 4, 5, 6. 6. That's hexanal. And also remember that this one too can also undergo a dehydration reaction to give up this is what we call the Aldol, which is the Aldol reaction. While for the Aldol condensation, simple, a molecule of water is removed between this carbon, in which this alpha hydrogen here will remove one hydrogen and this OH, which is, let me make it clearer to you. So here it's removed. So I'm now having something of this nature, which is a CH3, a CH2, CH2, then a double bond is being introduced, then I'm having, this is H, and remember having CH2, CH3, then having a CHO, so that the compound will become 2-ethyl, that's 2-ethyl hexan 2-enal. That is the product that is being formed here. Now, so many more examples. Now, in our next video, we'll be talking about what we call the reaction mechanism, how this Aldol reaction occur. For the now, God bless you, and please do well to subscribe to my YouTube video and your comment. God bless you. Have a nice day.